Hi, welcome. In this video, we're going to talk about functions in C++. So let's get started. All right, so top-down design just means you want to divide and conquer. You want to break up your program into smaller, different sections or sub-programs. So it's a very good idea to break up a larger problem into these subparts or programmer-defined functions. So of course, on your assignments, I give you kind of assignments from now until the end of the semester. We are going to be using functions, and we're going to break up problems into smaller parts called programmer-defined functions. And in C++, there are some rules on how you need to do it. And in this class, there are also rules in which I want you to do it. All right, so what is top-down design again? It's just breaking up a program's tasks into subtasks or little sub-programs called functions. So in C++, a function has a return type. So the return type of the function can be void, which means it doesn't return anything, or it can be any of the data types in which we've already studied, like int, double, char, or bool. So if any of these are the return type of the function, then it's called an integer function or a double function or a character function or a bool function. So functions are described by what they return. And so the setup is that the function has a return type. So it would have a return type, say it's an integer function, the return type would be integer. Then the function has a name, and then the function has what's called a parameter list. So you could pass this function that returns an integer. You could pass it an integer and a character and a double or whatever. And the order in which you pass this data, like this, is the order in which it gets the data. So we're going to learn about how to pass data to functions, but as far as the return type goes, at this point, it can only return one thing. It can either have a void return type in which it returns nothing, an integer return type in which it does its work and returns an integer, a double, a char, or a bool. All right, a function call is an executable statement instead of an expression. So what does that mean? If you have a void function, when you call that, it is an executable statement. So only a void function is an executable statement. So if you're going to call the function that has a void return type and it has a name and whatever its just say it doesn't take any parameters. If you want to call this function, you would call this function. This would be the function call, name, and that's a statement. Because it has a void return type, then a void function call is just an executable statement. Now, if this function took parameters, you would have to pass them into here, which we'll get to in a minute. Now, if you have an integer return type, that's a little bit different. So if my function has an integer return type, again, we'll just assume it has no parameters. So this is my function. This is a declaration for my function. So if I wanted to call this, I would have to say int x equals name, because this function, the return type of this function is an integer. So when this function gets called, it's going to return, you're going to jump into this function and it's going to return back an integer. So when this integer gets returned, because it's an integer function, you need to have somewhere for that integer to go. So if it's an integer function, a double function, a char function, or a bool function, the function call itself is an expression. This is an expression. It doesn't have it. It's an expression. What did I say? An expression? It's a combination of information that returns a value. So in this case, the value that's going to be returned from this function expression is going to be, because it's an integer, it's going to be an integer. If it was a character, it would return a character. If it's a double, it's going to return a double. And if it's a bool, it's going to return a bool. If the function is void, it returns nothing, then when you call it, it's going to be a statement because it doesn't have anything that's being returned back from it. So a void function is an executable statement, Any other type of function is an expression. A void function does not have to have a return statement inside of it. All right, so let's talk some more about functions. All right, we have three different things. We have a function call. So the function call is the expression in which you call it. Just like I said, if I have my function is called name, this would be the function call. And then if it's an integer function, it would have int x maybe, and then it would be part of the statement, but the function call itself is just the expression in which you call the function. If it takes arguments or has parameters, they're going to be in order and passed through these parentheses, which we will talk about in a minute. And we already said that a void function call is actually a statement because it doesn't return anything. The function, so this is the function call. The function call is where you invoke the function or call it or use it. A function definition is a block of code in which you put the code in that implements the function. And then there is also a thing called a function declaration. This is a single statement that tells you everything you need to know about the function in order to use it, and you should have very good comments on your function definition. You should add comments. And even more importantly, you should add good comments on your function prototype, because I should be able to look at a prototype and know what it returns, what it's going to do, what are the conditions that need to be set before I call that function, what are the post conditions that are going to be delivered to me after that function. So the function prototype is very, very important. So we will be stressing using function prototypes in this class, or another word for a function prototype is a declaration. Okay, so you don't need to know the implementation or the definition. What you need to know is how to use the function, and that is all set up in the function declaration or prototype. This is called procedural abstraction. So the idea is that we don't need to know, all I need to know if I want to use your function is how to use it, what the name of it is, what its return type is, and what type of parameters it takes and the order of the parameters, and some good comments that describe how to use it. And this is everything I just said. The declaration or prototype is very important, should have good comments, and it should explain exactly how to use the function. Another thing to keep in mind that when you have variables in your formal parameters, do not redeclare them inside the function. If you have parameters, those are the things. So if this is an integer function, the name of the function, and this is going to be the implementation, and it takes an int x, a double, and a char c. C and y and x will get declared when the function is called. So you do not declare them inside the function. That's the whole idea, is that those variables will get declared when the function is called. And if they're value parameters, in this case these are value parameters, they will not only get declared, but they will get declared and assign the values that are being passed to the function. All right, so a function, it's like a small program. Calling a function is like running its own small program. So in a C++ program, execution begins at main, and then you want to offload the work into little small subprograms called functions. So you put the parameters, go in order in the parentheses of the function when you call it. So when you're defining your function, it's called parameters. That's in the definition. And when you call the function, it's called arguments. The arguments are going to match the parameters. So the arguments of the function call, the arguments in the function call match the parameters of the function definition. The argument types match the formal parameters. I didn't even know it was going to say that, but the arguments match the formal parameters. A function can return any data type. At this point, the only data types that we're returning from functions would be int, char, double, and bool. These are the data types that we've been using so far in this class, and strings. We've already used strings. All right, a function that returns a bool value is called a predicate. Function parameters can be called by value or called by reference. So this is a big thing in C++. So call by value parameters, you must pass a value. It could be call by value can be a variable that has a value, or it can be a literal value. Call by reference must be a variable because you're not actually passing any value, you are passing a location. So reference, remember this term reference, it means that you're passing a address or a location. So in order to have an address or a location, you must have a variable. All right, when its function is called, its arguments are substituted for the formal parameters. So remember, the call is arguments, the definition is formal parameters, and they have to match. The two mechanisms for substituting parameters, I'm just reviewing. You have call by value. Call by value, the value of the variable or a literal value. What's a literal value? This is a literal integer. This is a literal character. This is a literal double. Those are literal values. If it's a pass by value parameter and it warrants, you can pass a literal value. If you're going to pass a variable to a pass by value parameter, that variable must have a value. That's why it's called call by value. Call by reference must be a variable because it's referring to the location of the variable. So when the variable will be substituted and any changes that are made are going to be made back where it was passed from. So this is a big feature. This is essentially a pointer. It's just that C++ has removed the need to dereference pointers by adding reference parameters. We're going to see some examples in a minute. To make a formal parameter a reference parameter, you add an ampersand. When the function is called, it is not given the values, it's given the memory location or the address. Is another word for it. Okay, scope and local variables. So just like with loops and the main function, everything in C++ is set up with curly braces. So if you have your function, this is my function, int name. This would be my function definition, int x, char y. I have an opening curly brace and a closing curly brace. And in here I have int z. Local variables to this function are x, y, and z. And they only belong to this function called name. They're in this scope. So when this function is called, it's going to declare an x and a y and assign those the values that are passed in. And then inside of the function, it's also going to declare a variable called z. These are local variables to the function. So the scope just means what's inside of the block of code that belongs to the function. All right, so here's an example. Here's an example of a double function. So this is a double function. That means it returns a double. That means that this function call will be in the form of an expression. So to call this function, you'd have to say double, well, you'd say double x equals total cost. And then it has two formal parameters. It has an integer called number. So you'd have to either give it a literal value here, or you could have int num equals 10, double price equals 35. So you could call this, you would pass it num and price, PR. So this is the expression part where you're calling the function. When this function does its work, it's going to return back. It's going to return back. This is a double. This double value will be returned back and then assigned to x. So when this function is called, that double value needs somewhere to go. And when this function gets called, number will get declared and will get assigned the value 10. Price will get declared and get assigned the value, this is a 35. 35. So you don't declare number and price inside the function again. They get declared when the function is called, and then you will see that they are being used in the function. So number will have 10, price will have a 35. This calculation will get done, and then this calculation will get done, and this whole value right here will get returned from the function and assigned to x. All right, so here is these are call by reference parameters. Okay, here's an example of a call by reference. So that was a call by value parameters. This is an example of call by reference parameters. So you see here this function, the parameters have an ampersand here. So this function right here is not taking values, it's taking addresses as its arguments, but you will see that these are used inside the function. The reason this says not recommended, because it's not recommended to cin two values with one cin. It would be better to do cin for parameter 1 and a different cin for parameter 2. And it would also be better to have a prompt like enter integer 1, then cin param 1, then enter integer 2, then cin. So that's what that not recommended means right there. So these are reference parameters. So, I realize you're just getting introduced to this, and your assignment for this module is going to have a couple of functions, and we're going to continue to do functions throughout the rest of the semester. So we're going to start out with just a couple functions and keep adding more about functions throughout the semester. These are reference parameters. You know that they're reference parameters because they have an ampersand. The placement in your code is to put this is the function prototype or declaration. It goes above main. See where the main function is? And then this would be continuing on. So the function definition is going to go below main. So in order to call this function, we are going to need to pass it to variables. The variables, so we have declared num1 and num2. This is a void function, so the function call is in the form of a statement. Num1 is going to, so in memory you would have num1 and num2, which have been declared here. And then what happens when this function is called, this is where, I'll just point it from here, param1 is going to go here, and param2 is going to go here. So when you read in the numbers from the keyboard, say you read in 2 integers, should be num1 here, num1. So you read in for num1, you get a 6, and param1, you get a 6, it's going to also go to num1. Param2, you get an 8, it's going to also go to num2. So back here, num1 is going to have the value 6, and num2 is going to have the value 8. That's how reference parameters work. So they're sharing memory with the function parameters and the variables that are in main. So these are local. Num1 and num2 are local variables in main, and param1 and param2 are local variables in the getToNumbers function. Then we have another function. This is a function that's going to also take reference parameters, and it's going to compare them. And if the first one is greater than the second one, it's going to swap them. If it's not going to swap them. So let's make the first one greater. So here we have num1 is 8 and num2 is 6. So I just changed them so that we're going to check here. So again, this is a function, is a void return type. This is the function prototype or declaration for that function, which is above main. This function tests values for swapping. So we're going to test. So we get, first thing we did is we get our two numbers, and now we're going to test the values for swapping. So we test the values for swapping. Again, we're going to pass. So if num1 has the value 8 and num2 has the value 6, we got them because param1 here got the, param1 got the 8, param2 got the 6. Now we're done with this function, and now we're moving on to the next function. The next function, param1 is going to be at the same address. I'll take these arrows off here. Param1 is going to go to that address. Param2 is going to go to that address. So now we're going to check. So the nice thing is if you took C, you would have to dereference and you'd have to go to value at, but by the way that C++ uses reference parameters, it will already dereference for you. So you're going to check if 8 is greater than 6. And if it is, you're going to call this swap values function. And when you do it, you're going to pass the 8 and the 6. But the swap values function, if you look, is also a pass by reference. So what's going to actually happen is it's going to point here to the 8, point here to the 6, and we're going to actually swap those values because that's what this is going to declare a variable called temp. Temp is going to store the 8. That's what this does right here. Then the 8 is going to change to a 6. That's what this does right here. And then the 6 is going to turn to an 8. So not only did we swap it in the function, but num1 and num2 have also been swapped. So a couple of things have happened here. We only called the test values for swapping function, but this test values for swapping function has called the swap values function. So even though we didn't directly call the swap values function from main, we did call the test values for swapping. Oh, and I forgot to put the function parameter, the function prototype is here. We did call the, when we called the test values, then the test values calls the swap values, and when the swap values function got called, it swapped the values, and so now num1 and num2, which were originally 8 and 6, have now become 6 and 8. And then our last function that we have here is going to be these are passed by value parameters. So what happens here in memory is we're going to have these two other variables. I'm just going to put O1 and O2. I realize that they're output 1 and output 2. Actually, I will put this memory over here a little bit more so I can write that. So just pretend that the memory continues. So this is output 1 and output 2. So these are values. So you notice that these are passed by value parameters because they do not have ampersands. So this is the function prototype for that one. So now we're going to call that function. When we call that function, num1, which started out as a 8, is now going to be a 6, and num2 is going to be an 8. This function is going to get called. Output 1 is going to get declared and assign the value 6. Output 2 is going to get declared and assign the value 8. And then it's going to print onto the screen output 1 and output 2 are going to get printed onto the screen. And this using namespace standard is here. And it's also here. You can put using namespace standard up here globally on your code, or you could put it inside of functions to make sure that you're using the standard namespace for C in and C out. All right, so again, these are call by reference parameters. We have parameter 1, parameter 2 for the getToNumbers. This is the function prototype for the getToNumbers function. The getToNumbers function gets called. We pass the locations of num1 and num2, and param1 and param2 are now going to point to those locations, and they will be used in here. So when these numbers get put in by the user, say the user puts these values in, then they're going to be put in by the user for param1 and param2, and num1 and num2 will also get modified because they're reference parameters. Then we have the test the values for swapping. Test the values for swapping prototype is here. We're going to call the test for values for swapping. So again, say that they were 8 and 10, then 8 and 6 would come in here. We're going to check, is 8 greater than 6? And if it is, you're going to call swap values. If the numbers that were put in up here were 2 and 3, then you would test 2 and 3, and you would not swap them because 2 is not greater than 3. But if they were 3 and 2, or anything in which this one is greater, then you'd call the swap values function. The swap value functions also goes by reference. So it's the same areas in memory. So all of these functions are all getting the same areas in memory. This one, and this one are all pointing to the same locations in memory where num1 and num2 are. So we have num1 and we have num2, and when this function gets called, param1 is going to point there and param2 is going to point there. So if you get the numbers 10 and 6, then when you call this function, this is param1, this is param2, 10 is greater than 6. So you're going to call this function. Then this function is going to declare a temporary. It's going to put the 10 here. It's going to swap the 6 and the 10. So now num1 and num2 have also been swapped. And then you have your pass by value function, which is going to declare new variables, output 1 and output 2, which are going to make copies. So output 1 is going to have a copy of the 6, and output 2 is going to have a copy of the 10. So it's going to print the 6 and the 10 onto the screen. But of course, you need to call the function first in order for it to work. All right, parameter versus argument. So a parameter is in the prototype or the declaration and in the definition. So those are the parameters, say the data type, and if it's the definition, it must have a name for the variable. An argument is what you use when you call the function. Call by value, you have to pass a value. So if it's a variable, it must have a value. Call by reference, it must be a variable. If you want to change the value of the variable inside the function, be sure to use the ampersand and use call by reference. Okay, a function may be called from another function. We just demonstrated that. Be sure to use function declarations above the main. Also, then they don't have any issues in which the order in which functions need to call each other, and it makes code much more readable. Stub and driver functions. So usually when you are starting out, you use your main function as your driver. So when you want to write a function, you write the function, and then to test it to see if it works, you call it from the main function. Sometimes you need helper functions in order to test your functions, and those are called stub functions. Usually the driver function is going to be the main. You write a function, you call it from main. Even if eventually it's going to be called from another function, you usually use the main function as the driver to test each function as you write them. And then sometimes you need an extra function, and that would be called a stub function. Preconditions and postconditions. You should get in the habit of putting good comments on your function prototypes or declarations. A precondition describes what must be true when the function is called. So in this case, param1, and in order to swap values, this function cannot, not only does param1 and param2 must be variables, but they must have values or this function will not work. So they must be variables, and you know that because they're reference parameters, but you also know that they must have values because they're going to be swapped. And then the postcondition is that they are going to be swapped. So precondition states what must be true to use the function, and postcondition states what the effect of the function after the function executes. So in this case, your function definition, you don't have to put precondition and postconditions on your function definition, but you really should put them on your function prototype or declaration, because I should be able to look at anyone's prototype or declaration and know how to use that function. These are the formal parameters, what needs to be true about the parameters, what's going to happen in the function. I should not have to worry about how it's actually implemented. I should be able to just look at this and know how to use it, and that's the idea of abstraction and the black box. All right, so here's, again, these are call by value parameters. So they make their own copies. And these are call by reference parameters because they have ampersands. Now, in this example, I realize that all the functions have call by reference parameters or call by value parameters, but it is possible you could put combination of call by value and call by reference parameters. Like a function can have, you know, an int and a character reference. There's no rule on, and it could return an int, but we're not doing that right now. We're just dealing mostly with void functions at this point, but we will be adding integer, double, and character functions. All right, so you can have any combination of formal parameters that you want. Another thing you can see here is this function right here. I have changed it from pass by value parameters to constant reference parameters. Now, constant reference parameters must have values because you can't change their value inside the function. So sometimes, why would you want to do that? Well, if your data is large, there's no reason to make extra copies. Pass by value parameters always make a copy. So maybe you don't want to have extra copies in memory. So if you pass a constant reference parameter, it does ensure that it's going to be values. It just is going to share the location in memory. So you can also do that as well. Okay, we haven't really gotten into functions that return things, so that is going to be coming up soon. We're going to focus first on void functions, so we will be talking about overloading functions in the near future. And also these are functions that have, this has a double return type. We did talk a little bit about it, but in our next assignment we will, in the assignment for this module, we will just be using void functions, and then in the next assignment we will be using functions that have a return type other than void. All right, one thing I want to remind you is when you're testing things, use cout statements, common, all the time, to check what's going on in your code. It will be very helpful for you to follow what's going on in your code.